Definite integral. We learned that definite integral can be defined as a net area, which is the difference of the areas of the region which is placed above the x-axis and then below the x-axis. We also remember that the definition of the definite integral holds a value of the function, not absolute value of it, just the actual value. And since the function is placed below the x-axis, the value is negative. That's when we're subtracting an area. That's the net area. That means let's solve a few problems using the net area. Example number 1. Evaluate the following integrals by interpreting each in terms of the areas. Integral from 0 to 3 of the function x minus 1 dx. We can take the function x minus 1 is just the linear function. Y-intercept is -1, x-intercept is 1. I can draw a line, -1, 1, and limits of integration are from 0 to 3. Then I see that my integral will be a difference of the area above the x-axis and the below the x-axis. We did create two triangles. Let's say this is A1 and this is A sub 2. That means this integral, this integral from 0 to 3, x minus 1 dx is equal to A sub 1 minus A sub 2. Let me let's find an area of the top triangle. The formula for the area of the triangle is 1/2 base times height. And I see that the base is the distance from 1 to 3, which is 2, and the height is the value of the function at 3. If we substitute 3, 3 minus 1 is 2. That means the height is also 2. 1/2 times 2 times 2 is simply 2. Okay, that means we do have 2. The area is 2. And now, using the same formula, I will compute the area of the lower triangle. 1/2 times base times height. 1/2. Base is just 1. We can see it. And height is also 1 unit. That means this is half. But since it's below the x-axis, I have to subtract. The integral, a definite integral, equals to 3/2. Example number 2. Evaluate the following integral by interpreting each in terms of the areas, which is the next integral. Okay, integral, definite integral from 0 to 1 of the square root of the quantity 1 minus x squared dx. That means, first of all, we have to know what's the shape of this function. Probably we can't tell right away, or maybe some of us, but let's rewrite this function. Let's square both sides and let's add x squared to both sides. And now we can nicely see that the equation x squared plus y squared equals to 1 represents a circle with the center 0, 0 and radius 1. However, we have to be careful because taking this equation, and if I will reverse this process, which means I want to solve this equation for y, I will subtract x squared from both sides, and then I will take the square root. But taking the square root of both sides, I will have positive and negative answer. And my integral includes only positive. That means this is only a positive part, the upper semicircle. The lower is not included because we only have positive. And that means it's not the full circle. And now the limits of integration. Okay, I'm taking this function and I have to cut the limits from 0 to 1. That means theoretically, I mean practically, it's just a quarter of the circle. Okay? I think I have a nice picture for you. Okay, quarter of the circle, and we know what's the area. The area of the circle is pi r squared, and since it's a quarter, I have to divide by 4 because it's just a 1/4. And radius is 1 in this case. It's just pi over 4. I think I typed this. This is a really nice example how we can use the net area to evaluate definite integral. Example number 3. The same thing, evaluate the following integral in terms of the area. Absolute value of x is not as complicated as the semicircle. We all know the graph is just negative and positive part. And my limits of integrations are from -1 to 2. This value is 1 and this value is 2. And that means I see the areas under the curve and below the x-axis, that triangle. And I also see this one. Both of them are above the x-axis. That means both of them are positive. Let's see, I can say a sub 1. A sub 1, a sub 2. This means an integral from -1 to 2, absolute value of x dx will be the same thing like the area of the first triangle plus the area of the second one, because both of them are above the x-axis. The first one is half times base times height, which is half times 1 times 1. This distance is 1 and this distance is 1. It's simply half. And the other one is the same thing, 1/2 times base times height. The base is 2 and the height is 2. It's simply 2. And we can add the numbers together. It's 1/2 plus 2, 5/2. Also a really good way to get an integral of the absolute value. Another function, and we have to get the value of this definite integral through the net area. Integral from -1 to 2, absolute value of x minus 4 dx. And this integral, we may use the properties of the integral. I can split for 2 integrals. Absolute value of x minus the integral of 4 dx. Of course, keeping the same limit. And then I can take care of the first one, which actually the first one is my integral from the previous problem. And I think we got 5/2. And integral of the constant, it's also a beautiful concept because it is constant function, right? Y equals to 4, just the horizontal line. And we can cut the limits from -1 to 2. And we do have just the rectangle. So we do have 5/2. And since it's the, please do not mistake this with the subtraction, the net area. Subtraction is because that was the function, that was the expression, the integrand. Yeah? We just respect the original question. It has nothing to do with the net area. The net area is still positive because it's placed above the x-axis. The area of this triangle is base times height. Height, of course, is 4, and base is 3 because it's 3 units with between -1 and 2. Okay. 5 halves minus 12. 12 I can rewrite as a 24 over 2, negative 19 over 2. I think this makes sense. Okay. And I have another one. Evaluate the following integral in terms of the area. Now my function is 2 square root of x. It's almost, the graph is a little bit slimmer because each value is multiplied by 2, but it's still absolute value. And the limits of integration are from -4 to 0. My graph is, can draw a little bit higher, and let's find, this is the region, that's the triangle. A little bit taller because multiplication by 2. And what is the value, the corresponding value, because we will need for the height of the triangle, what's the corresponding value of the function at -4? I can substitute -4. This will be the value at -4. 2 times absolute value of -4 is +4, it's 8. And I can place my function here. And the value is 8. That means the integral from -4 to 0 to absolute value of x dx equals to 1/2 base times height, 1/2, and base is 4 unit and height is 8. 16 is the final answer. We may also use the property of the integrals, and we can put the constant outside the integral and just focus on the function root x. Thank you.